All right, so if you were absent, we're gonna go ahead and do a video over notes 54. All right, so we have two different kinds of domain and range. We have discrete and continuous. As you can see, discrete is dots. So it looks like just dots on a page, where continuous looks like a solid line. So just remember discrete, dots, continuous is a line. All right, so if we're going to just look at the dots, we're gonna look at discrete. Domain is all the x values. So my x value of this dot is -3, and we list them from least to greatest and don't double any numbers. This is -2, this one's 0, and here is +2. So all I did was bring them all to the x-axis. What number is it? And then range, I'm gonna bring to the y-axis. So this is -1, this is 0, 3, and 4. Okay, so on number 2, I'm gonna do it again, same thing. I'm going to bring them to the x-axis for domain, least to greatest, so I'm gonna start at the left. That's a 2, 3. There's 2 of them at 6, but I'm not gonna do repeat numbers, 6, and then 7. Then range will go to the y. There's 2, 3, 4, 6, and 7. Right, that's different than when we have continuous. When we have continuous, whoops, sorry. Okay, when we have continuous, we have a solid line. So we're gonna find the 2 endpoints and squish them up to the x-axis. So here's as far left as this shape goes is right here at -4. And as far right as the shape goes is over here at 3. And then if I squish this whole line, that's what it would look like on the x-axis. All right, so I can see that my domain on the x-axis is everything from -4 and 3. But I can't just write the numbers -4 and 3. I actually have to create the inequality. So I need to show that x is everything in between -4 and 3. And we can see that these have lines underneath them because they are solid dots. See, there's a solid dot at 4, a solid dot at 3. All right, so on number 3 and 4, we have the same thing. I can see that if I pull this to the x-axis, my lowest number is 0. If I pull this to the x-axis, my biggest number is 7, and everything would get squished in between. All right, on number 4, I can see that this would come down right here to 1. That would be my furthest left point. This would come to 5. That would be my furthest right point, and this whole line would get squished down to the x-axis in between. So I can see it goes from -5 to 5. All right, the difference between number 5 is I have an endpoint on the furthest left, but on the right I have an arrow. I can't put an endpoint. Okay, an arrow tells me I'm just gonna keep on going. All right, so since I only have one endpoint and not 2 endpoints, I'm only gonna have one number and one inequality sign. So my important number is 0, and all of this shading is in front of 0. So I would pick greater than, x is greater than or equal to 0. All right, on the back. So we need to ask ourselves, do we have 2 endpoints, 1 endpoint, or no endpoints? So the furthest left I can go, I have an endpoint, open circle at -5. The furthest right I can go, I have an endpoint, open circle at +5, and everything else would get squished in the middle. All right, so if I have 2 endpoints, I need x in the middle. I will always use less thans. I won't ever use greater than. And I'm gonna decide what numbers x is in between and if they can be equal to. All right, so We already said the lowest is -5, the highest is +5. They are both open circles, so neither one gets a line. All right, on number 7, when I'm looking at this shape, the furthest right I can go is right here, and the furthest left I can go is right here. All right, so when I'm looking at this, I know there's 2 endpoints. So I'm going to put my X, start with my less thans. Now I need to figure out the numbers and if they get lines. Well, the furthest to the left it goes is 0. And I don't see an open or a closed circle there, so I have to look at the lines. Remember, we have open and we have closed circles. But if I don't touch a closed circle at that, I need to look at lines. Remember, we had dotted and solid lines. So this at 0 is a solid line, so it does get a line underneath. And then the furthest right it goes is 4. And it's an open circle, so it does not get a line underneath. All right, on 8, I need to decide, is it 2 endpoints, 1 endpoint, or no endpoints? All right, so I can see I have 1 endpoint. The furthest left I can go is a solid endpoint at -2. But this is an arrow, so I would shade right on past. So even though there's an arrow there, it's not an endpoint. It tells me to keep going. So I only have 1 endpoint, so I'm going to have 1 inequality. My important number is -2. It is shading in front of -2, so that is going to be a greater than, and it's a filled in circle, so it gets a line. All right, on number 9, remember, an arrow tells me to keep going. So if I was to shade this way, I would keep going past that arrow. This arrow tells me to shade this way and keep going past that arrow. So do I have any endpoints? Okay, nope, I don't have any endpoints. It just keeps going, and this is called all real numbers because it can be any number. And you might even see this little symbol. All right, number 10. Do I have 2 endpoints, 1 endpoint, or no endpoint? So I'm going to go to the furthest left, and I see an arrow. That arrow tells me to keep going. And I'm going to go to the furthest right, and I see a point. So I'm going to shade everything in between, and if I see an arrow, I'm going to keep going. All right, so I can only see 1 endpoint. That tells me I'm only going to have 1 inequality and 1 number. My important number is 3. It is shading less than 3. And it's a closed circle, so I get a line underneath it. All right, so I want you to finish 11, 12, 13, and 14. I will be checking them on your binder check.